Hello, I'm Mr. Morgan, and welcome to your first video lecture notes. It's entitled Fundamental Variables and Units, and the place to record your notes is on page 26 in your notebook. The essential question that we're trying to answer for this set of notes is how are variables, units, and constants used to describe the natural world? Go ahead and write down the essential question in the essential question box on page 26 along with the date. As we take notes, feel free to write down questions that you'll have for me in class, or maybe you want to look up the answer to later on that side question section that you see next to where you take notes. There's also a section marked Summary at the bottom, and that's where you're going to use the collected information to answer the essential question for each set of video lecture notes. Let's go ahead and begin. In this physics class, we're going to encounter two main types of numbers, constants and variables. Constants are numbers that have a set value and they never change. So something like the speed of light in a vacuum or the number of inches in a foot, those are constants and they don't depend on anything else in the physical world. Variables are numbers that have values that depend on other variables and they can change over time. They're affected by other things in the physical world. Whether you're writing down a constant or a variable, it's really important that you write units afterwards. Units are the physical objects that the numbers represent, and it gives you an idea of what we're talking about, right? So if you record a number and you say 12, well, 12 miles is very different than 12 inches or 12 elephants. If we look at this table below, we can take a look at some of these constants. So a dozen is always 12 no matter what. A cup is a set volume. But things that might change is the height of a person. That can go up and down over time, usually up for a while and then down towards the end. The amount of money you have in your pocket, that can rise and fall. The speed of the car, the time it takes to do something can also vary. Now in physics, there are only 6 variables that are known as the fundamental variables that all other variables are made up of. Now you notice that there's a little star next to that, and that just kind of means that there's a little bit more to the story, but it's not something that I really want you to worry about, unless something physics is something that really interests you, and you can talk to me about it on the side, or maybe one of the other physics teachers. But those fundamental variables are time, distance, mass, charge, color, and spin. And in our class, we're really just going to focus on time, distance, mass, and then later on, charge. The first fundamental variable we're going to be looking at is time. Time is how long an event takes to occur in the physical world. We measure time in minutes, hours, seconds, centuries, months, but many of those units have some variance, so a month isn't always going to be the same amount of time. Years sometimes have leap years, and so in physics, and physicists mostly focus on the fundamental unit of time, which is the second, right? So we're going to be measuring things in class in seconds. The next fundamental variable we're going to be looking at is distance, which is also known as displacement. Distance is how far apart 2 points are in space, and the units for distance are inches, miles, feet, those kinds of things, but we're going to be using the metric system. So we're going to be looking at centimeters, and our official unit for distance is the meter, and it's about the length of a leg. So here's a little picture for perspective. About the top to the bottom of our whiteboard is about a meter. The next fundamental variable is mass, and mass is a little bit tricky because it's not how much something weighs. Mass is how much stuff an object is made of. It is almost a quantity of atoms that are globbed together to make up an object. Mass is not the same as weight because you can be absolutely massive, but at the same time, you can be weightless. Weight is a measurement of how much gravitational force is being exerted on that object. But the more mass you have, typically between two objects, you're going to have more weight. But we'll get into that later on. Our units for mass are going to be grams and tons. Pounds are, I put a star next to there because pounds is technically a measurement of force, but pound is something that you're a lot more familiar with than a gram or probably a kilogram. The official unit we're going to be using is the kilogram, and if you want to picture a kilogram in your head, I want you to think of a pineapple. We'll also use a lot of grams, and a gram is about the same size as a paperclip. So here's our picture of a pineapple just to help you remember a kilogram. If you ever get stuck on any of this, on page 5 in your notebook, there's a handy dandy reference table for you to access, and it just kind of breaks down variables, the symbol for that variable, a description of sort of what that variable means or represents in the real world, and the unit that we're going to use mostly in physics class. So the final part of our notes is going to be the summary, and this time I'm going to write the summary for you or with you to kind of give you an example of what I think the summary should be. But in the future, I want you guys to do your summaries on your own to kind of show your understanding of the content that we did. So your first step would be write down the essential question: how are variables, units, and constants used to describe the natural world? And when you write your summary, you're going to try to use the information from the notes to address that in your own words the best that you can. So in my own words, the collected information I had to answer this was that every numerical value has a variable, symbol, and unit related to it that describes something real. The variable is important for being able to communicate in a common language with other scientists. The symbol will save you time and be used in equations where we don't know what something is. Like, so if you have an unknown, you can place a symbol in there. And finally, we have to remember to use units to turn plain numbers into something real. So always have your units and make sure that we're always relating back our equations and values into concepts that we're learning about. Okay, that's it for this first set of slides. It was also my first recording ever, so hopefully we'll get better at this as time goes on. And if you guys have any suggestions, email them to me, and that's all.